In part A, you are to use the power rating to determine the resistance of the bulbs. So use P equals to V squared over R to determine the resistance of the two bulbs X and Y. You will get this answer over here. Moving on. Okay, in part B, if you look at the wiring, it's a bit strange. There's something wrong with it, and this is not the way that we should wire our power sockets at home. So this shows the path of the current. So if you trace the path of the current, from the live wire, current will flow in via this live terminal. It will go through the appliance, the first bulb Y. It will exit via the neutral wire. But by right, this neutral wire is supposed to connect back to the power grid neutral terminal. But instead of that, it's wrongly connected. So current will continue to flow, not to the grid, but towards the live terminal of another socket, and then flow out, passing bulb X, and then exit the neutral wire, and then going back to the neutral wire in the grid. So you notice that actually there's only one path of current through Y and through X. This must mean that X and Y are now connected in series, side by side with each other. So when you connect both bulbs in series, the issue is if one of the bulbs blow or stops working, or if you switch off one of the bulbs, then the other one will also not work because they are in series. You break off the circuit, both bulbs in series will not function. So that's the drawback. Now, which of the bulb is brighter? You might be tempted to choose the 100 watts bulb to be brighter. That works only if the voltage applied to the bulbs is 240 volts. If you apply 240 volts to both bulbs, then the power rating tells you that the 100 watts bulb Y will be brighter. However, this is not the case in this question because these two bulbs are connected in series across 240 volts. So you just picture a 240 volts power supply, and then you have two bulbs sharing these 240 volts. The idea of potential divider equation comes in actually when you have two bulbs connected in series. The bulb with the higher resistance will grab a bigger share of these 240 volts according to the potential divider concept. So revise on potential divider concept if you need, and therefore because the 50 watt bulb has a higher resistance, go back to the calculation just now, because the 50 watt bulb has a higher resistance, it will grab a bigger share of the 240 volts. That is the reason why in this case the 50 watt bulb will be brighter because the voltage across the 50 watt bulb X is higher, leading to a higher power. So in part C, this is how we should wire out our power sockets at home. Behind the walls in our house, there is this power grid, and there's this main three wires, the earthing wire, the live wire, and the neutral wire. And every power socket that we have in our house is connected via this way. You must memorize in the power socket which hole represents the earth connection, which hole represents the live connection, and which hole represents the neutral connection. And if you connect the power sockets like this, every single power socket is connected in parallel to one another. This allows us to control the different appliances independently of one another because parallel circuits are independent of one another.